Hello, Assalamualaikum warahmatullahi wabarakatuh. We are from Cyanide Group. Today we are going to present about our sugarcane production project. Our aim is to produce 5 million ton per annum of thick sugar solution. So we move to our first equipment, which is shredder. Shredder has 85% efficiency. So our feed is 271 at 746.183. Goes into M1. The efficiency of the component at M2 is 15%, while at M3 is 85%. So we obtain our flow rate at M2 as much as 2310934.255 kg per hour. While for the energy balance, for a shredder, we only use the power of the shredder itself, which is 4026845.638 kilojoule per hour. Moving on to crusher. Crusher has 95% efficiency. We use 4 stages of crusher. Okay, so the input for crusher is the same as output from shredder. We obtain the output from crusher as much as 2500363.667 kilogram per hour. As for the energy balance, it is same as shredder. We only use the power of the crusher. We obtain the energy use as 5369127.52 kilojoule per hour. Moving on to screener. Screener is the same function as filter. We want to filter the fiber. So at M7, we have 62.7 fiber removal efficiency. So fiber will be removed at M7. But okay, we obtain the fiber removed from M7. The fiber that will be removed is 948182.126 kilogram per hour, while the rest will come out from the M8. The total is 2806040.365 kilogram per hour. For screener, there is no energy balance needed because no energy is used. Proceed with buffer tank. Buffer tank is used to store the juice. It has 62.7 efficiency. The input and the output is just the same because it's only used to store. So the output from buffer tank is 2806.040.365 kilogram per hour. Then there is no energy balance needed for a buffer tank. So this is equal to 0 joule per second. That's all from me. Thank you.
Okay, next we move to the next process, that is a heater, the first heater before the clarifier. Okay, in this heater we just heat from 40 degrees Celsius to 50 degrees Celsius. The mass flow rate that entering the heater is around 3 million, and it's same with the outlet stream because it doesn't affect the mass flow rate. It just increase in temperature. So the energy balance of the first heater is we calculating the enthalpy. It is the 131 million of kilojoule per hour. Okay, then we continue to the next process. It is the clarifier process. In this clarifier, we need to clarify the sugarcane juice by mixing them with calcium hydroxide and carbon dioxide. Okay. Okay, the mass flow rate of the sugarcane juice that entering the clarifier is around 3 million that at the from the outlet of the heater, and the mass flow rate of the calcium hydroxide is around 190,000, and the calcium and the carbon dioxide that we use is around 113,000. The mass flow rate of the sugarcane juice that at the outlet of the clarifier is around 3 million 920,000. So the energy balance that we have been calculating in the clarifier is 4,160,000. Okay, next we move to the next process, which is the second heater after the clarifier. We increase the temperature from 50 degrees Celsius to 70 degrees Celsius. The mass flow rate that entering the second heater is 3,920,000, and outlet is the same, and the energy balance at the second heater is 2,524,000. Okay, next we must filter the sugarcane juice to remove the filter cake. Okay, the mass flow that entering the filter is 3,920,000, and the outlet stream, the mass flow rate of the juice is 3,465,000. The energy balance that has been calculated is by calculating the power usage only, that is 10,800.
So the next process is evaporator. In evaporator, there is three effects. In the first effect, the mass flow rate in is around 3 million, and mass flow rate out and enter to the effect 2 is around 1 million, and then mass flow rate out from the effect 2 and enter to the effect 3 is around 691,000. Okay, so for the energy balance in the first effect, the enthalpy juice is around 6 million kilojoule per hour. Enthalpy for steam is around negative 6 million kilojoule per hour. And in the second effect, the enthalpy for juice is 762 million kilojoule per hour, and enthalpy for steam is negative 762 million kilojoule per hour. And in the last effect, the enthalpy for juice is 269 million kilojoule per hour. Enthalpy for steam negative 269 million kilojoule per hour around. And so the total enthalpy for evaporator is around 7 million kilojoule per hour. Okay. Next is crystallizers. In mass flow rate for crystallizer, enter to the crystallizer is
around 570,000, and mass flow rate molasses that out from the crystallizer is 51,000, and water out from the crystallizer is 49,000, and the mass sugar crystal from the crystallizer is 500 and around 503,000. The energy balance for the crystallizer is around 12 million kilojoule per hour. For the separator, the mass flow rate that enter the separator is 555,000, and mass flow rate that up from the separator is 503,000, and the energy balance used is 14 million kilojoule per hour. Next, in the dryer, the mass flow rate in the dryer is around 503,000. Mass flow rate out, first mass flow rate out is 427 and 437,000, and the other mass flow rate out is 76,000, and the energy balance, the enthalpy used in the dryer is around 18 million kilojoule per hour.
Okay, we shall carry on with boiler. Boiler is the process where it is cogeneration of the electricity. So the bagasse that we got from screener as well as the crusher is sent into a boiler, and this boiler is a fired tube boiler. In the boiler, the amount of water and amount of air is calculated based on the literature review, which is 1 ton of bagasse is equals to 2.5 ton of steam produced. And this steam is sent into turbine, steam turbine. Steam turbine will be rotating and will produce electricity, where it will be sent to a generator. From the generator, it will be separated into two, where 36 kilowatt per hour, which is around 3.6 megawatt, will be sent to the mill for the use of the mill, and the rest will be sent to a transmitter to be transmitted out from the industry. And after the steam line is after the turbine, it will get into condenser, and in the turbine the pressure will be decreasing. And once the steam entered the condenser, the temperature change will occur there. So this water partially will be sent to evaporator, and the rest will be sent to a second condenser, where in this second condenser the temperature will be reduced even more to make sure that it can be a suitable water condition to enter as a feed water for the boiler. The bagasse that has been combusted completely, will be sent to fuel stack. That is all for boiler. Lastly, we shall carry out with the costing from the Cyanide company. This is the summary of Cyanide cash flow. Our total capital cost consists of ISBL, OSBL, contingency costs, as well as engineering and construction costs. That would sum up around 5 million plus. And we produce around 3,384 tons of raw sugar per year. From literature review, we got the price of the raw sugar is 1,764 per ton, and our sales, the sales we got from production rate multiplying with the price that we got it from literature review. Our operating cost consists of sugarcane, chemicals that we use, which is CaOH as well as carbon dioxide, and the amount of water we use. That would bring us around 300 million, including the labor cost as well as plant overhead, together with the maintenance. And lastly, we had our revenue as well as cash flow.
and our cumulative cash flow. We only started earning back our profit at the end of the year 3, where we started off with 5 million. And finally, after 20 years, we got back a very huge amount of profit, which is around 101 billion. That's all. Thank you. Thus, finally, as a conclusion, we able to achieve our goal, which is to produce 5 million ton of thick sugar solution per year. That will bring us around 3 million plus raw sugar ton per year. That is all from Cyanide Company. Thank you.